Alrighty, let's take a look at number 5. They want us to use the IVT to show the following. Show that the equation this must have a solution. So the approach for A is to get everything on one side by subtracting the 4 to the x so that everything is equal to 0. So we're going to sort of treat this as our f of x. Okay, so we're going to just test out values. Say f of 1 and f of 2. So we're plugging in x equals 1 and x equals 2. And if we can show that one of those results is positive, one result is negative, and that the function is continuous, then we can show that that function equals 0 at some point between 1 and 2. If we plug in 1, we get 2 to the first, 3 to the first, and 4 to the first. So 2 plus 3 minus 4. That's 5 minus 4, so 1. That is a positive. If we plug in 2, we get 2 to the 2, 3 to the 2, and 4 to the 2. So we get 4 plus 9 minus 16. That's 13 minus 16. That's negative 3. So it goes from a positive to negative as x goes from 1 to 2, which means f of x, or this expression, f of x, or this expression, is equal to 0 at some point between 1 and 2, which means 2 to the x plus 3 to the x minus 4 to the x equals 0 at some point between 1 to 2. In other words, if you add that 4 to the x back over, this equation holds true at some point between 1 and 2. Okay, let's do part B. Let f be continuous. F is bounded by 0 to 1. From 0 to 1, show that f must have a fixed point. In other words, f of c equals c. Hint, define a new function. Okay, so eventually, we're trying to show there's some c for which f of c is equal to c. In other words, like c is just an x value, so we're trying to show that there's an x value for which f of x is equal to x. In other words, like the y value's equal to the x value. So we come up with this new function, kind of like the approach we did in this previous one. We subtract everything to one side, right? So we subtract the x to the other side so that we have everything equal to 0. So this becomes our new function that they're talking about, the g of x. So we want to use this to show that there's got to be some x value or c value for which f of c is equal to c. So let's play around with this. Let's plug in 0 and let's plug in 1. So finding g of 0 would be f of 0 minus 0. Okay, well, f of 0 minus 0 would just be f of 0. And then let's plug in 1. F of 1 minus 1. That is just going to be f of 1 minus 1. We really can't do anything with that. But what do we know about these? Well, f of 0, all the f values are bounded between 0 and 1. And f of 1 minus 1, well, let's start with f of 1. We know f of 1 is between, again, 0 and 1. But now let's subtract 1 from all three of these. Negative 1, f of 1 minus 1, and 1 minus 1 is 0. So look at what we have here. We have that g of 0, which is f of 0. G of 0 is between 0 and 1, inclusive. And then g of 1 is between negative 1 and 0. And so it's so close, but it's close to saying that g of 0 is positive and g of 1 is negative, right? It's very close to saying that, but it's not quite. And the reason is we have a chance of g of 0 being equal to 0, and we have a chance of g of 1 being equal to 0. That's the only thing stopping this from being positive and this from being negative. So we have to run all three cases. The case 1 would be if g of 0 is equal to 0. Let's explore that case real quick. G of 0 being equal to 0 means that f of 0 minus 0 is equal to 0. And that just means that f of 0 is equal to 0, which, if you think about it, we are just trying to show that f of c equals c for some c on 0 to 1. So in this case, we have found that to be true for c equals 0. So that's case 1. Case 2, how about g of 1 is equal to 0? So in other words, g of 1 is equal to 0 here. So what would that mean? That means that f of 1 minus 1 is equal to 0, which also means if we add the 1, that f of 1 is equal to 1. So regardless, case 1 or 2, it still shows that f of c equals c for some c on 0 to 1. So c is equal to 1. So now case 3 would be, once again, if g of 0 is not equal to 0, and if g of 1 is not equal to 0, that does show that g of 0 is positive and g of 1 is negative. So case 3 is, again, g of 0 not 0 and g of 1 not 0, which then confirmed that g of 0 was positive or negative. What was it? Yeah, positive. And then g of 1 was negative, right? So that means by the intermediate value theorem, if we plug in 0 and we get a positive, plug in 1 and get a negative, as long as g of x is continuous, that means that g of x is equal to 0 for some value on 0 to 1. Well, if g of x is equal to 0, that means that f of x minus x is equal to 0, because g of x is f of x minus x, which means that f of x is equal to x for some c value, for some x value on 0 to 1. So really, there exists a c for which f of c is equal to c. Really, I guess these could have been c's the whole way through here by the IVT, right? So the point is, no matter which case we come across, like, it's still showing that f of 0 is equal to 0, f of 1 equal to 1, f of c is equal to c for some c on 0 to 1. Okay, hope that makes sense. If you have any questions, let me know.